Hello friends, welcome back to our channel. And today I have come up with a question for you, and the question is, we are being given with a shear force diagram as you can see on the board, and we have to draw the loading diagram and the bending moment diagram. I'm pretty sure that all of you, being out of touch from so long, must have got some sort of forgetfulness in these things. And today we'll be discussing these things in detail, how we can develop loading diagram and bending moment diagram from a shear force diagram or vice versa, whatever will be given. So it's quite easy. I will give you a simple trick. If you stay with me in the video, you will be able to solve any kind of problem based on such things. And the trick is, it's not a trick actually. It's actually the sign convention that I have simplified. For example, whenever you are having a beam and you want to analyze it regarding with respect to its shear force or bending moment, whatever you are trying to analyze, and there are two approaches. Obviously, you can go from the left hand side of the beam, or you can go with the right hand side of the beam. But while we go from either from left or right, we start analyzing, we always get confused with the sign conventions, which moment to take positive, which to take negative, which direction of loading to take positive and which part of loading to take negative. I must tell you, there is not a certain convention in the world that is being followed. It wholly depends upon you, and different textbooks follow different conventions. But I'm going to give you a convention that wherever you'll apply it, you'll feel that, yeah, I have done it correctly. Now the convention is, just remember this diagram over here. Just remember this diagram over here. If this is my beam, and whatever I am drawing, and that denotes positive. Whenever you analyze the beam from the left hand side, always take this direction of force as positive, and these types of movements as positive. Whenever you analyze the beam from the left hand side, if you are encountering this direction of force, you take it positive, or you are encountering the clockwise direction of movements, take them positive. And if you are analyzing it from the right hand side, then take these direction of forces as positive, and this direction, that is anti-clockwise movement, as positive. So just remember the sign convention. Just remember this diagram. Upwards, downwards, this side and this side. So always remember the diagram. Whenever you are analyzing, you have to take these things positive. And if you encounter opposed direction of movement or opposed direction of load, then you have to take that negative when you are analyzing it from the left hand side. And if you are analyzing it from the right hand side, then take these sort of directions as positive. And if you are encountering the opposite directions, then you have to take them negative. Now I will show you this question, how we'll solve it based upon this. Now see, let's draw the let's draw the loading diagram first. From this, then we can easily draw the bending moment diagram. So since I said, let me draw it here. Let me draw my sign convention here. This is positive. If I am analyzing from the left hand side, then these things are positive. This is for shear force, and this is for bending moment. And if I'm analyzing from right hand side, then I have to take the downward shear force as positive and the anti-clockwise movement as positive. Now since I will analyze the beam from the left hand side, then I will take these things positive. See, when I am analyzing, I have to start from this point. Now starting from this point, I am getting a shear force of 2 kilonewton. So obviously, when I have upward direction of shear force, then that means this positive. Now see, this is the shear force diagram. Now I have to draw the loading diagram out of it. Obviously, when I am analyzing the beam from the left hand side, when I have a shear force of 2 kilonewton, and that too positive, that means the load has to be in this direction. Obviously, there has to be a support over here. If I will draw the loading diagram over here, see, at point A, I am getting a shear force of 2 kilonewton, that too positive. Now, what my convention says, according to my convention, the force when I'm analyzing the beam from the left hand side, this force is positive. This force is positive. That means I have a force of 2 kilonewton upwards. So I cannot load the beam like this. So that definitely there has to be a support at A, which whose reaction is equal, for example, RA, and it's obviously equal to 2 kilonewton. Okay, it's so simple. If you just follow this sort of signing convention, you'll be easily in no time. If I'm taking time to understand, make you people understand about the whole process. But if you once understand the thing, you understand this logic, then obviously it will take no time to analyze it. Now see, obviously RA is equal to 2 kilonewton. Now see, SFD. This is the SFD, obviously. So SFD consists of inclined line in portion A to B. A to B. Let's analyze it up to this point for now. From point A to B, it consists of an inclined line, obviously. And whenever we have an inclined line in SFD, just remember it's always subjected to UDL. And the loading rate is given by, if you want to calculate the loading rate of the UDL, you have to do one thing, the simple one thing. If you want to calculate the loading rate, which consists of this inclined line, then loading rate will be equal to W1. If I name it W1, then you have to do one thing, the final value minus the initial value divided by the length. The final value minus initial value divided by the length. What is the final value? That's 0. And what is the minus? The initial value 2. And what is the length? That is 1. So I will get it minus 2 kilonewton. Minus 2 kilonewton. And what does this minus denote? This minus denotes that the loading is downwards. Okay, because my loads, when I'm analyzing from the left hand side, these loads have to be positive. The upward loads, which are going from down to up. This type of load is positive for me when I'm analyzing from the left hand side. Now since I'm getting negative value, that means the load has to be like this, downwards. So that's why the sign is negative. So from the beam is subjected to the UDL of 2 kilonewton per meter up to B. Fine? Fine? So I hope everyone is enjoying it and is understanding it. It's so simple. Now let's come to this part, B to C, this inclined part. And obviously, as I told you earlier, whenever we have an inclined shear force diagram, it means that the part is subjected to UDL. Now what I said, how to calculate the intensity of the UDL, you have to do one thing. What is the final value? That's 6. And what is the initial value? What is the final value? It's 6. But what 6? It's minus 6 because it's downward side. So you have to keep it mind to use the proper signs. So minus 6 minus this final, and what's the initial? That's 0. And what is the length divided by length? That is from B to this point we have a length of 3 meters. So 3. That means minus 6 divided by 3, you get minus 2 kilonewton per meter. So this load up to B, it's not only up to B, it's up to C actually. So this load is up to C. We have a UDL of from A to C of 2 kilonewton meter. Now what happens at C actually? So what happens at C? Here at point C, at point C, the SFD changes drastically. It changes from minus 6 to plus 6, and obviously whenever we have a drastic change, then you should think of support. You should think of support at that point. So hence there will be a support at C, and the reaction at C will be that we will calculate. Now see how to calculate that reaction. See, we have support over here. Now the reaction is equal to the whole of the thing. Since this is 6, this is 6. So it has actually gone from minus 6 to plus 6. That means the reaction is 12. Okay. Now that means we have support over here. Now the support can be fixed or they're hinged. Now we assume those are hinged right now. Then I will be explaining it later in the video. If you'll stay with me in the video, you'll be be understanding it fully, that the support, whether it's fixed or hinged, and we'll be calculating it whether it's a hinged support or a fixed support. Okay, just be with me. Now see after this point, after we get a support over here, and the reaction is RC is equal to 12 kilonewton. Now from C to D we again have an inclined line, and whenever there's an inclined line in SFD, think that the load is UDL. Okay, now since the load is UDL from this point to this point, how to calculate the intensity of that load? Obviously this is plus 2 final value minus initial value, that's 6, divided by 2. So we get minus 4 divided by 2, and you get minus 2 kilonewton meter. Now friends, I should not explain it again. I think I should assume that you are understanding the minus 2 kilonewton means the loading is downwards, because as per my sign convention that we have just remember this thing. Just remember this thing. These are for positive values. This upward load, whenever you are analyzing, this for positive, and the clockwise movement is for positive. Now whenever we have a negative value, that means the load is downwards. So obviously this portion CE is subjected to a load of 2 kilonewton, UDL of 2 kilonewton per meter. So this means this 2 kilonewton per meter is actually it's separated the whole of the beam. From A to D point, the beam is subjected to a UDL of 2 kilonewton per meter. Now see, we have a change in shear force. See, from point plus 2 to 0, it is actually coming down. Okay, because when we are analyzing it from some side, say right or left. Now when we are analyzing from left, you start from this point, move to this point, then move to this point, then you are moving to this point, then you are moving to this point. Now then ultimately you move to this point. Now from this point to this point, there is a drastic change. The load has changed. It has changed from 2 to 0. That means we have a downward force. We have a downward load of 2 kilonewton. So that means here my beam is subjected to a downward load of 2 kilonewton. Now let's calculate the moment. Let's check the nature of the support C. Now for support C, since it's the intermediate support, we have loading on the both sides. So we have to actually do the algebraic sum of all the moments from both sides, and to know whether there exists some movement or not. If there exists some movement, that means it's a fixed support, and if there doesn't exist any movement in total, that means it's a hinged or roller support. Now see guys, see, if I do the equation like this, if I calculate the summation of moment about C, that will be equal to, we have to take either, if you take clockwise movement as positive and anti-clockwise movement as negative, so we have to do this thing over here. Now summation of movement about C is will be equal to the movement due to, we'll calculate due to the support A, so whose magnitude is 2, and what is the lever arm, that's 4. So let's take clockwise direction as positive over here. Now this UDL from A to C, this will be actually giving a movement of this direction, of anti-clockwise direction, about point C. So we'll calculate that. That's 2 into the total load first, 2 into 4, that is the 8 kilonewton is the total load from A to C, multiplied with its lever arm, that's 4 by 2, or you can say 2 directly. Okay, now what about this? This will give a movement of clockwise direction, this 2 kilonewton load, so we'll be taking it positive, so 2 into 2 up to point C, so 2 into 2, and plus again because this UDL from this point, from point D to point C, this is again giving a movement of clockwise direction about point C, so it will be positive over here. So that means 2 into 2, that will be total load, and what is the lever arm? 2 by 2 or 1 directly. So this is 8, this is man 16, this is plus 4, this is plus 4. So 8 plus 4 plus 4 is 16, plus 16, and man 16, that will be 0. So again we are getting the summation of movement about point C. The total movement about point C is 0. That means this support over here at point C is either hinged or it's a roll support. Okay, hope you have understood the concept. Now I hope if you apply this concept, and you will be doing this thing very easily. Now I want to draw the bending moment diagram, and we'll be knowing some more concepts. Okay, we'll be drawing the diagram in general, we'll be making some equations, and we'll be knowing about what the point of contraflexion is and what about the point of inflection. Okay, and those are very important for interview purposes as well as in the exams they are asked. Now let me rub this first. Okay, let me rub this first, and let me rub this loading diagram as well. So we'll make it in a compacted form over here, so we can draw the bending moment diagram easily. let me draw the loading diagram over here first. Let's draw it over here. So my whole beam was subjected to 2 kilonewton load, UDL of 2 kilonewton per meter. So I was having a reaction of 2 kilonewton, as I remember, at point A, and at point B, at point C, I was again having a reaction of let's RC, let this be B, RC is equal to 12 kilonewton, and about at point D, I was having a point load of 2 kilonewton, and this bar was 2 kilonewton per meter. So this was all about the loading diagram, how we should decode the shear force diagram and create loading diagram out of it. Now let's draw the bending moment diagram. It's so easy to draw the bending moment diagram if you know the concept, if you know how to frame the equations. Now let's analyze the portion AC, because the portion AC is having a uniform shear force. Okay, now let's analyze the portion AC. Okay, now let's frame an equation, bending moment equation for AC in terms of X. Now if I say like this, if I say in portion, let me write over here. If I say portion AC, so this portion AC, okay, will say from A, we'll use X distance from A to C. Okay, and in terms of X, I'll be having a bending moment equation of R A into X. Okay, minus, and what minus? Because see, if we go again to our sign convention, which says these clockwise movements are positive. So due to the load, this support which is acting upwards, it will always give me a clockwise movement. So that's why I'm writing it as positive over here. So RA into X. So RA, whatever X it will be, it can be 1 meter, 2 meter, 3 meter, but its upper limit is 4 meters, because we have a total of 4 meters from point A to C. Okay, so RA into X. Okay, and minus is because this UDL, it will be giving me a load of it will be it's obviously downwards, and if I calculate the movement due to this UDL, it will be always and always clockwise. So my positive movement is anti-clockwise when I am analyzing from the left. Okay, and if I encounter any clockwise movement, that will be considered as negative in the equation. So that means minus 2 into x square by 2. Okay, because 2 into x is the total load which I will be considering, and x divided by 2 will be the lever arm up to that point. Okay, so what is the value of x? X is what? X is, it will be less or equal to 4. It will be greater or equal to 0. Okay. Now what about when? Now what about if I simplify it further? I will be having RA into x minus x square. What about when my x is 0? What about when my x is 0? If I put the x is equal to 0, that means at point A. So that means at point A, my movement will be 0.